So I might be slightly blinkered, and from what you've heard from me in Scotland just now, it is a very positive place. But electrification, particularly in Scotland, is in a very positive place here. After all the trials and tribulations in CP5, a really positive environment has been created to challenge the norm and really push the boundaries. This is the complete opposite to what we had in CP5, where it was a bit like paint by numbers, and we were all blindly following standard practice, regardless of the hardships it was bringing us, and there were plenty. But now, up here in Scotland, we've been given licence to be really innovative, to really challenge the designs and challenge the guidance, and or in some cases, jump back to where things were done years ago. We've got automated design softwares that churn out detailed designs in a fraction of time it used to take. We've been able to challenge the design rules, like the maximum tension lengths, where we've managed to get back up to 1,700 metres up here in some cases. We've got new technologies and products appearing all the time, all with the aim of making electrification more efficient. Vista are looking at rolling out a 1,400 metre half tension length Tensorex unit, which would be a massive reduction in overlaps. Fura and Frey, who are in today, have recently launched their composite mast, which could have a huge saving in cost and carbon. And Mott MacDonald, one of our design partners, have their wooden cantilever prototype, which again could prove a significant cost and saving cost and carbon. There are loads of other things out there, and these last three might take a little while to go before they prove they can be worked and rolled out. But the key is the environment is there for people to really push the boat out. But all these ideas will only bring benefit if the government commits to funding new electrification. And as you've heard, here in Scotland, we're in a very fortunate place, where the government and Transport Scotland have committed to the rolling programme of decarbonisation, which is what we're going to try and do by 2035. From a delivery perspective, though, we're not really near where we could have been after 3 years of doing pretty much nothing on site up here. And all that training and knowledge of the previous 8 to 10 years has fallen away. But we are now very much underway in delivering the first schemes of this programme and trying to rebuild that skill base once again, and hopefully for the last time. On Barrhead electrification, after a little bit of false start last year, we're actually starting piling next weekend. On Haymarket to Dalmeny, we'll see the first piles going in the ground at the end of June, beginning of July. On the Fife Corner, in the northern part of Fife, we've just submitted yesterday the Form A. And in Borders, which is actually probably the most advanced from a design perspective, we pretty much have an AFC design sitting on the shelf ready to go. And then we've got the poor cousin, the traction power guys, where we're trying to upgrade the existing network and make it ready for the new electrified routes. The first new feeder station at Fergusley, west of Glasgow, is due for commissioning in the coming months. Now, I know nothing of these giant fuse boxes, so if anybody wants to find out anything about them, Stephen Lynch or Brian Sweeney's standing over there. And it's also great to see lessons being learned from previous. And we're actually underway with CP7 design works to Aberdeen and Inverness, which would hopefully mean that once these CP6 schemes are finished, we're hitting the ground running. But we're all too aware that funding is only available for this funding is only available, sorry, I'm not even moving. The funding is only available for this rolling programme if we meet the not inconsiderable cost challenge to get the STK rate down to where Transport Scotland need it to be. And from what I can tell, there isn't really much of a choice. We have to get it down to that rate, or we'll find something else to do. We've already made significant gains in getting that STK rate down, which is evidenced by the fact that we're actually starting construction works. But there's still a way to go to create the environment needed to consistently meet and better those targets. But what have we done here in Scotland to get where we are already? Essentially, we've been going through every aspect of what it takes to design and build electrification. I looked at ways to make it as efficient as possible, to try to simplify and standard everything we do and make it a production line. We've both been looking at what went well and badly in CP5 schemes, both in Scotland and wider UK, in terms of strategy, plan and methodologies. I looked to deploy some of the good practices and learn the lessons from the less successful ones. And I was involved in a few. Making electrification efficient is a full industry effort. But to me, from a delivery perspective, there are 4 key principles. To reduce the boots on ballast, track access is expensive. To maximise time on track when you do go there. To reduce civil works as much as possible. A phrase I use a lot is that the overhead line solution is always the cheaper one. And minimise abortive works and design change post-AFC. We won't eliminate it, but we need to be in a position where we are sure that the design will work when we turn up on track with all the materials and manpower. There are loads of little initiatives we've been looking at, but there are a few key technologies and methodologies that we'll run through today that are really making a difference to us to help meet these 4 principles and drive down cost. The first, and it's already been mentioned so far today, is the digital twin. And I'm sure a few of you have heard it and used it. The driving force behind this in Scotland is Colin McAteer of Network Rail, and it's been successfully deployed in Borders in the northern part of Fife, alongside the design partners Mott MacDonald again, who have really embraced this. Essentially, we've got a 3D mesh taken from drone footage that can have any design model referenced into it. And the big key for me is we can access it online. We do not need any fancy CAD skills to work it, which is good for us delivery guys. As you can see, it's almost video-like quality, a bit like a cab ride in steroids, and gives both construction and design a clear picture of what the finished design will look like and identify the constraints around it. And bonus points for anybody that can identify that stadium. It's a bit niche to the Scottish market, to be honest. No. Rafe Rovers, Start Spark. So what are the benefits? Well, from a construction point of view, constructability reviews can be undertaken from the safety and comfort of your own home. Miles of track can be covered in hours rather than days and days spent out on track, or nights and nights. We've also used it for design reviews, IDCs, IDRs, hazards, signal sighting, even listed building consents, and identifying environmental and social constraints. It's actually harder to find something that it's not useful for. The IDCs that we've had with this are a huge step change because it allows you to reference in interfacing designs, and it stops the whole jumping back and forward between route view cab rides, Google Maps, and the 2-dimensional design that we've got. There's still very much a place for a 2D design in an overhead line because it gives that helicopter view of the design, but there really is no comparison to using something like this. The biggest problem we've had with it, though, is we've not actually got it available in all the projects. Borders and Fife, we've got it. East Kilbride and the southern part of Fife, not so much. Another technology we're looking at deploying is GPR, which we're using to reduce the volume of trial holes prior to piling and to reduce the overall length of the piles. Trial holes, for those that don't actually know, is essentially a 1-metre deep hole that we dig by hand to search for services. Then we fill it back in and then stick a foundation in it. It's time-consuming, expensive, and actually adds additional length to the pile by increasing the non-effective depth. And from a health and safety perspective, it's also a little archaic. Sending humans down a hole to find cables is like sending canaries down the coal mine. Now, Network Rail Scotland looked at GPR as a way to reduce that pile length and carried out trials with GeoInfo, a specialist surveyor, over a number of sites to understand the accuracy and the outputs, and those were very positive. And after initial reluctance on my part specifically, we've been very much brought into this and have started a much larger scale trial on Barhead and Haymarket to Dalmeny, where over 450 locations have been surveyed to date. We're currently carrying out a 20% check on those to build up our confidence in the technology, but the aim is to reduce that 20% down as confidence grows. Alongside the reduction of pile length, in some cases that can be up to 25%, which in Scotland means we're actually less likely to hit rock. The biggest benefit is that 20 to 30 locations can be surveyed in a single night, rather than 1 or 2 trial holes being dug. And even when you factor in the processing time, which is about a week, this is a massive reduction in programme and time spent on track. This won't stop trial holes entirely, but it allows us areas to be targeted, like stations and junctions where we've got complex areas, and areas where we do find services, but we can't move the foundation out the way. But there are some slightly wider benefits to using this, due to the output from the GPR being in CAD, and essentially becoming an accurate, up-to-date, buried services model. And if the survey is done in a timely manner, then this becomes an input to the design, rather than services becoming something we react to post-AFC. On Haymarket to Dalmeny, we've actually managed to supply this to Atkins, our designer, prior to the IDC for the Form B, which has allowed the design to be updated and gives us the surety of foundation installation, or certainly more sure, which will reduce on-site change. But the real goal, though, for me, is to do this survey as part of the Form A. And this is really possible due to the accuracy of things like the automated design tools and iTwin, which allows us to go on site with confidence at that stage. Moving away from the technology part, we're working hard to reduce the civil requirements in projects. A wise man who's now moved to Saudi Arabia actually once told me that the more you involve civil engineers in overhead line projects, the more expensive it gets. The recent EPTANs and voltage control clearances and parapet heights have already brought significant savings, but we are more looking at the overhead line foundations, both what they are and where they are. Piling is still the go-to for efficient installation, and with the reduced pile depths we are now getting through a reduction in non-effective depths and the use of actual loads instead of 75% yield strengths, this will only improve. But it's the non-standard and bespoke foundations that we're focusing on and have the potential to cause us significant problems if we don't get it right. Rock is probably the biggest cause of bespoke foundations in Scotland, and it's a thing we've got a rather lot of. I've used many solutions over the years to deal with rock, but it's always felt that we were never quite got it right, mainly because we were never quite sure where it actually was. So we've decided to try out all the various methods we've used in the past and see what was actually best. Our lead civil engineer, Mark Craig, arranged a few days at Cloburn Quarry, along with our pilot contractor, Story, and our borders designer, Motts. Cloburn, for all you PWI types, is where you get most of your ballast from in Scotland, and is a red granite quarry, which would provide a significant test for the trials. So they tried out techniques like down-the-hole hammer, micro-piling, coring and augering to understand output, limitations, set-up times, even measuring noise, all done off-track in a contained and safe environment. And the outputs were, with the exception of the coring, which was hopeless, they have all have a place in our armoury, but depends on the situation you're faced with and the access that you have. Micropiles was superb, went through the rock in no time at all, but it does require a bit more design time to actually pull it together. And there's still the issue of transferring from the micropiles to the mast, which we are actively working on. The down-the-hole hammer was brilliant as well, but it's incredibly noisy, and it takes a long time for setup costs. But it still has its place. Disruptive possessions, disruptive access. Once you're on track and you've got yourself going, it's a very good output, and you end up with a pile at the top. And the the augering still has its place, where if we identify rock where it's only the last metre or so, you might as well spend the time just doing that rather than bringing in expensive down-the-hole hammer. But the key to knowing what to use and when is knowing where the rock actually is. We spend millions in GI to inform design, but for me, the most essential part is knowing the actual depth of rock at each location. Spending the time and money doing that is worth it, as it gives us a surety of the foundation installation. We've just completed a few nights at the weekend of probing in Barhead, and we actually decided to use a 6-inch mast and a Movax, which we drove down to find the rock level. And now we know exactly where, over 50 locations where we knew there was shallow rock, where that rock level is. And this was done over 2 or 3 nights, so it's very inexpensive. It's certainly worth it. And we can now plan that installation of each of those foundations with a degree of confidence. Moving forward, we hope to do this non-intrusively, using a technique known as atomic dielectric resonance. And I have no idea what it does. It says, however, this is another geoinfo offering, and it's used out in the rigs to identify rock profiles and soil properties at 200-300 metres on the ground. So I'm assuming it can find our rock at 2 or 3 metres under the ground. And the hope is that we'll run this in parallel with GPR surveys in areas of known shallow rock. There is a little work required to get to there, but the technology is absolutely there. Another efficiency we've been looking at, Spanlens, specifically as a way to reduce bespoke foundations, but it may have wider benefits if we prove it works. The viaducts across the River Almond as part of Haymarket to Dalmeny is unsuitable for attaching traditional gallows brackets. So we challenged our designer, Atkins, to span the viaduct to avoid installing foundations 10 metres below in the floodplains. We're still working in the design and modelling, but it looks very much like we can make a 90-metre span work using equipment from their existing UKMS, with a little tweaking of the cantilevers. Well, I've just been informed this morning we've probably got a cantilever in the range that will give us a 2-metre system height, which is marvellous. Now, this will potentially save around $250,000 from that project alone, plus the maintenance issues that have come from the foundations more or less being in the river. But should the modelling prove favourable, there's a potential to not only reduce the expensive viaduct attachments we install, but also to really push the boundaries of the 65-67 metre span length limit in UKMS to a much higher value, to significantly reduce the overall foundations we actually need to install. And if we're able to do that using existing equipment within the range, then it's good for everybody. I suppose I should really talk about overhead line construction as well. Our entire construction strategy is around minimising the works done on track by doing as much off-track work as possible. Off-track works are safer, cheaper, and it's much more efficient. This essentially means we're going to attach everything onto the masts in the yard prior to taking it out on site. SPS, number plates, DP stocks, earthwire connections, bonds, everything we can possibly get on the mast will be going on before we take it out on track. And we're also going to pre-register the cantilevers in the yard and take them to site, attach them to the mast on the ground and lift it in one go. This approach will reduce the normal 3 or 4 visits to each mast, hopefully down to a single visit. It also removes the working at height requirement by taking MUPs out of the equation altogether, as this can be done with an RRV and a couple of trailers. This approach will be hugely beneficial in Scotland, where STCs make up the majority of structures, but we're also looking to apply this principle with portals and TTCs. And we've even started seeing if we can attach switches onto the top of portals and masts as well and taking them to site. But it's all about logistics and in the prep. But there are a few things needed to make this approach work. Design maturity to allow the ordering materials and number plates, which become very expensive if you go out with a MUP to go and install them. Get all these things in advance. Accurate survey data and as-built from the foundation is an absolute must to ensure that we attach all the equipment at the correct height. And one of the biggest things for us is patience. We've all been in projects where everyone was jumping up and down, trying to get you on site just to see progress. As Colin Finlay would have called it, the "Are we there yet, Daddy Brigade?" But this approach needs all the materials available and all the designs up to date before lifting a finger. No longer do we run out and install a foot a mast or two just because they're in the yard. We also need pretty much all the foundations in a given area finished before we start. On the Shotts Electrification in CP5, the overhead line team waited until there was over 600 foundations installed before they installed a single mast. But within 6 weeks, they'd caught them up. And then they were stood down, which is obviously very expensive. But with this approach, with only a single visit to most locations, we'll close that gap even quicker. So patience and timing is everything. A rolling programme will really benefit from this methodology, as the foundation teams and then the overhead line teams will just roll from one site to the other. Once the overhead line team's on, the foundation should be installed further on. To be honest, we've not actually managed it in Anger particularly yet, because none of the designs have been in a place where we want to do it. On Barhead, we managed to get the SPS up, but we haven't had the cantilevers. So I'm sure we'll come across some issues and have to tweak our outputs and methods. But starting Barhead in the next couple of months, this is very much the way we're going to be doing it. With the use of all these technologies and methods, amongst other things, we are very much on the way to meeting that STK rate aspired to, and we will continue to work to make improvements, but it's very much dependent on there being a rolling programme. We cannot put all this work in for this control period and then spend 3 years with no site works again, as we have done so this time, as we'll just lose all that experience and knowledge again. But there are a few big items that can still be done to make electrification more efficient in Scotland. Funding and volume of works. Contracting small 20, 30 kilometre sections, or even worse, releasing a scheme piecemeal, where we design a bit, build a bit, design a bit, build a bit for that continual cycle, is actually the worst of it all. We need to get to the place where large volumes of work are contracted in a single event, both design and build, to prevent all the stop and starting and let us make use of all the tools that we've got. Progressive assurance is another area we need to work on, an expression everyone uses but nobody seems to know how to make it work. In design, with all the automated softwares and technologies we're deploying, like the iTwin, we're trying to take the Network Rail project engineers on a journey with us, keeping them involved and sighted of everything that's happening, but yet we still have a 4-week review period from Network Rail for every single design submission. I'm aware this isn't probably the case elsewhere, but it's still very much where we are. And there's a lot of work putting into it, but 4 weeks is longer than a lot of the designs actually take to produce. Similarly, in construction assurance, we've created an entire new industry for assurance, with armies of people employed to do what used to be done by a few people. Sorry, keep my notes. There are lots of softwares that have been created to help with this, and they are genuinely superb. We're using Synchro in Scotland, I know EV-File and others are used elsewhere. And what they can do is really, really good. But we have to think about what we are asking to be recorded on site, to prevent supervisors needing secretaries with them to complete all their online forms for everything they do and touch. I'm not saying we do away with this aspect at all, more that we really need to discuss what is needed to be recorded and by whom. The terrible events at Carmont should really shine a light on what is needed to be recorded and why. And for me, it's change. Change to design, change to materials, change to on-site conditions, not endlessly recording torques of every bolt installed and where we put the snap head pins. And the last part, and possibly the biggest area for potential efficiencies, as possession access. Standard rules of the route, which is what we're delivering Barhead on at the moment, has to be discounted for all new electrification projects in the future if we're going to have half a chance of achieving these required rates. 4-hour possessions with an actual productive time of 2 hours each night is just not sustainable. But on the flip side, blockades are also not the answer, as they come with their own enormous logistics and resource issues. And at the end of the day, the railway is there for the passengers, so we cannot close the railway continually for long periods without severely denting passenger numbers in the long term. So a balance has to be struck. Extended rules of the route has to be the answer. An extra 2 hours of night actually doubles output from standard rules, but we should also look at when those possessions actually occur. Even though COVID here in Scotland apparently ended on Monday, the use of public transport is very different to what it was before COVID, as we've heard. Weekend and leisure travel is now more popular than regular commuting. And as we've heard, freight is a massive growth area. So we need to tailor how we shut the railway for our works to meet those changes in use. Weekends might not be the best time to provide the longest access. It might be Tuesday and Wednesday because they're the quietest days in the railway now. It may be that working daytime is also better on some routes, possibly working 10 in the morning till 4 to let the peak services run either side. But whatever it is, hopefully we can all agree that 2035 for decarbonisation will not be met working 2 hours a day. And a final point from me. For most of my 20 years working in this industry, it's been built in overtime, with people working 60 and 70 hours a week. But the people who work on site have had the same epiphany as the rest of the population due to COVID. With a few noted exceptions, the majority no longer want to work 6 and 7 days a week continually. Work-life balance is a thing all people are striving for, whether they work in an office or out on site. That goes for bank holidays and Christmas working as well. We can no longer expect everyone just to turn out on Christmas morning because we bribe them with bonus shifts. Family comes first for most people now. And we know we have a small workforce. Despite 10 years of trying to grow it, I think there's a stat where before CP5 we had less than 250 linesmen. Now we've got 350 despite all the work that we've actually done. So we still have a small workforce. So we need to create a working environment that caters for this fact and does not just flog people for a few months and then expect them to cater for themselves for the rest of the year. Because without those men and women on site, we have no chance of decarbonising this railway. Thank you.